Okay, John, this is a demonstration of the ServoSlowDown device that I have built for you. This is the primary circuit board here. As you can see, there is a lead coming off of it that plugs into your receiver. I've just got a little inexpensive park flyer type receiver there. And then there's another cable that goes off into which you plug your servo. And I've got just a little inexpensive GWS servo here, and I've got a little piece of tape, a double-sided tape on the bottom of it to keep the servo steady while I demonstrate this for you. Of course, a standard 4.8 volt battery is plugged into the micro receiver, and here's my transmitter, Futaba 8-channel transmitter. I've got it connected into channel 5, so you'll hear me flipping this switch back and forth as the servo rotates. I'm going to show you here where the set screw is that controls the servo's speed. It's this little variable potentiometer. Excuse me for getting off center here every once in a while, but I'm having to try to record this and hold it all at the same time. It's this little set screw right here is the one that does the work. I've got it set right now to the, I'm going to set it to the maximum speed position. This will rotate the servo as fast as this device is able to rotate it. When I'm done here, I'll plug the servo directly into the receiver and let you see how fast the servo rotates on its own. But this is the fastest speed possible using this device. That's from one extreme to the other, and I have it, as I said, I have it in channel 5 on my transmitter so that I get instantaneous switching from one direction to the other. Now I'm going to turn the set screw down just a little bit. Let's go maybe halfway and show you the difference that it makes in the speed of the servo. I chose this servo because this is not an expensive servo. This is actually a very inexpensive servo that has very coarse resolution. And by that I mean the steps that this servo recognizes between one extreme and the other are pretty coarse compared to a better servo. If you have a finer servo or a finer quality servo, your resolution will be much better and you'll see even smoother movement than you see here. But I'm going to zoom in real close here and try to let you see just how smooth the operation is, even using this cheap GWS servo. Now that's about the halfway position on our little potentiometer, and as soon as it gets to the extreme there, I'm going to go over here and I'm going to change this again and go to our slowest position. And this position is so slow that that servo just creeps, and yet it doesn't jerk. It still moves very smoothly. You may be able to hear it clicking as the gears mesh inside of it, but the movement of the arm is still very smooth and very, very consistent from one side to the other. Let it go through that range again. I haven't timed it, but from my recorder I'm using here, it looks like it's probably taking something in the neighborhood of maybe 15 or 20 seconds to go from one extreme to the other. Train going by outside, that's not the servo making that noise. Okay, the circuit uses two integrated circuits to perform what we're doing here, and there are easier ways to do this with programmable integrated circuits that require much fewer components, but every other method that I've tried thus far has given me a very jerky motion on the servo, and this has been by far the smoothest operation I've been able to accomplish thus far. The circuit board, of course, can be trimmed down a good little bit to save a little bit of space. The circuit itself is very lightweight. The components don't weigh much at all. I haven't weighed the board itself, but it won't weigh more than a few grams. But I'm going to send this to you and let you see if you think this would do what you want to do on the radio controlled boats, and then we'll be in contact. I can let you know how much I can build these for, and if you're interested, you can tell me how many you need, and I can tell you how long it'll take me to get them to you. Thanks, John. Bye. Okay, John, I'm going to have to stitch these two little video movies together for you, because I had to lay the camera down to where I could unplug the servo slowdown circuit. I wanted to show you how fast this servo moves from one extreme to the other when it's just connected straight to the receiver. There you see my receiver and battery. I've got the servo slowdown circuit unplugged, and you'll see the difference now. That's how quickly that servo rotates from one extreme to the other when it's connected directly to the receiver, and you can compare that with the speeds that you were seeing from the first video, and give you a frame of reference. Thank you.